Next, we have an object moving in uniform motion. So these were the case of object, at rest at a particular distance or at the origin itself. Now we are making the object move. So for that, actually, I can go with this itself. So this is a case of uniform motion. You can see the object is covering equal distance in equal interval of time. Right? And so the distance time graph, let me squish it. Yeah, the distance time graph, displacement time graph, they are straight line with what kind of slope this is? Yes, positive slope. While the velocity time graph is flat, but it has a positive value. The slope is 0 though. Acceleration is 0. Please don't look at the minus first part. That's because of my programming. So we are looking at displacement time graph, velocity time graph, and if the object is moving from origin, the graph will look like this. If it's not moving from the origin, it will look like this. So for any point of space, if I take up any run, the rise will be the same. That's the whole point of having uniform motion. So let me show that actually. So I'm just taking 2 points. This is my run and that's my rise. So if I copy this and I can check out any 2 different points, see this? The rise by run is not changing. So that's why it's called as uniform, right? While the velocity can be either a positive value, a very small positive value, a very small negative value, that is, it can be going the opposite direction. But it has to be what? Parallel to x-axis. So this is parallel to x-axis. Okay. And then we have acceleration time graph. So what about this? Yes, it would be a line somewhere over here. Depends. Nope, that's wrong. What is happening with the velocity? Is it changing? It's not. So acceleration will be a flat line like this. Okay, so here I was not able to show it properly, but okay, something like this, right? Can you see that? It's 0. 0 and it's running over there, and velocity over here is 100 and it's running. So in my graphs, you always have to read it properly. Don't assume that it starts with 0, So can you see that? Things will not start with 0. It can start anyhow, right? And yeah, you need to understand all the variation. An object can start off at any point. It's starting at random point. Starting or not starting at origin. More than that, it's not at. So this is not starting at origin, and this does not indicate where it's starting. It just indicates that it's a positive value or a negative value. And it's moving at constant rate. That's it. Nothing to do with where it starts from. And by the way, this is the heading. So let's see if I have spoken about everything. Uniform motion, constant velocity, position time graph, positive velocity, negative velocity. I showed that. Graph can start from any point on the y-axis that I showed. Velocity time graph. Oh, okay. So what it means is this. So in distance time graph, you can have such graphs as well. Displacement time graph, you can have this as well. This indicates the object is going backward. That is, it's moving in the negative direction. Need not be backward, but it's moving in the negative direction. And again, it can be any way, guys. It can be this, it can be this. Okay, all these possibilities are there. So not only this, so I can show one more. Even this is a possibility. This too is an example of starting at origin, and this has a negative velocity, but it's constant. This is positive velocity, and this is negative velocity. And what else? Yeah, acceleration. The graphs will flip if the object is moving with negative velocity. Okay.